Hello, this is Miss Peterson. We're going to go over our 4-4 notes on solving exponential and log equations. So there's just a couple of steps involved in solving exponential equations. The first thing we're going to do is we're going to isolate the exponential expression. We want some base to the x power. We want that on one side. And then the second step is to take the log of each side. The third step is to expand the log by using the power property, and then we'll solve for x. So a short example here. We want to solve for x. We have 2 to the x power is equal to 16. We already have our exponential expression isolated. We have a base to the x power. So the next thing we're going to do is we're going to take the log of both sides. So we have log of 2 to the x is equal to log of 16. Please note that there's no base right here. We're using our common log of base 10. So next step is to expand the log using our power property. So we have this x here. We'll bring it down. So we have x log of 2 is equal to log of 16. And then the next step is to solve for x. So in order to get this x alone, we'll divide this side by log base 10 of 2, and this side by log base 10 of 2. And so that gives us x equal to log base 10 of 16 all over log base 10 of 2. And x is going to equal 4 if you plug this into your calculator. And because, remember, it's our common log of base 10, we can just use our log button on the calculator. We don't have to go into math and go to the changing of base sort of step there. All right, so for our next example, we want to solve for x. So just gonna move these out of the way here. All right, so our first example, we have 5 to the x plus 2 equals 28. So we already have our exponential expression isolated. We have some base to x, and x power is equal to some number. So the next thing we'll do is we'll take the log of both sides. So we have log base 10 of 5 to the x plus 2 is equal to log base 10 of 28. All right, next we'll use our power property. Bring this x plus 2 out in front. So we have x plus 2 times log base 10 of 5 is equal to log base 10 of 28. All right, from here, we'll divide this side by log base 10 of 5, and we'll divide this side as well. So this gives us x plus 2 is equal to log base 10 of 28 all over log base 10 of 5. And then just to get that x alone, we'll subtract this side by 2. So we have x equaling log of 28 all over log of 5 minus 2. And if you plug this into your calculator, you're going to get around the answer of 0.0704. All right, so our next example, we have 6e to the 2x equals 40. Please notice that we have our base e to the 2x, but we don't have an isolated exponential expression. We need to divide by 6 to get the expression by itself. So we have e to the 2x is equal to 20 over 3. It's 40 over 6, and if you reduce that. So the next step is we're dealing with a base of e. So when we have a base of e, we're going to use the natural log. We're going to take the natural log of both sides. So we'll take the natural log of e to the 2x is equal to the natural log of 20 over 3. All right, so the next step, we have our power. I'm going to bring it down. So we have 2x, natural log of e, is equal to the natural log of 20 over 3. All right, and the natural log of e is equal to 1. So side note, natural log of e is equal to 1. That's why we use the natural log when dealing with base e. So we're going to have 2x times 1 is equal to ln of 20 over 3. All right, so this is really 2x is equal to the natural log of 20 over 3. We want that x alone, so we'll divide by 2. So x is equal to the natural log of 20 over 3, all divided by 2. All divided by 2. And if you plug this into your calculator, you're going to get around the answer of 0.9486. All right, so our next example. We're going to solve for x again. Let me just move these down so we have a little bit of room. So we have 4 times 2 plus 3 to the 4x is equal to 80. So we need to isolate our exponential expression 3 to the 4x. So the first thing we're going to do is divide both sides by 4. So we're going to have 2 plus 3 to the 4x is equal to 20. All right, and after that, so we're going to subtract this 2. So we're left with 3 to the 4x is equal to 18. So note now we have our exponential expression isolated. We have our base to a power of x, and it equals a number. So we're going to take our log base 10 of both sides. So rewriting this, we have log of 3 to the 4x is equal to log base 10 of 18. So we have using our power property, we're going to bring this 4x down. So we have 4x log base 3, or not log base 3, log base 10 of 3 is equal to log base 10 of 18. From here, we're going to get that x alone. So we'll divide off by log base 10 of 3, log base 10 of 3. This gives us 4x is equal to log base 10 of 18 all over log base 10 of 3. Still getting that x alone, so we'll divide by 4, and we'll divide this all by 4. So we're left with x equaling, if you plug this all into your calculator, x equals 0.6577, or around there. All right, for our next example, I'll move this down again. I write a little large. So we have 2 to the 1 minus x is equal to 3. So we have our base to a power of x, so our exponential expression is isolated. So we'll take the log of both sides. We have log of 2 to the 1 minus x is equal to the log base 10 of 3. From here, we have, using our power property, bring this 1 minus x down. So we have 1 minus x times log base 10 of 2 is equal to log base 10 of 3. From here, we will divide off by log base 10 of 2. So what we have left is 1 minus x is equal to log base 10 of 3 over log base 10 of 2. We want that x alone. We'll subtract 1 from both sides. Negative x is equal to log base 10 of 3 all over log base 10 of 2 minus 1. All right, from here, we need to get rid of this negative 1. So we'll multiply by negative 1 both sides. So that gives us x is equal to a negative log base 10 of 3 all over log base 10 of 2. Oh, let's put the negative on the outside. Sorry about that. And then we have our addition. We add 1. So if you plug this into your calculator, you have x is equal to 0.6577. All right, so for our next example, we want to solve for x again. So we have 5 to the x is equal to 4 to the x plus 1. We have exponential expressions on both sides, but that doesn't matter. So they're both isolated. We have a base to some x power. So we have log base 10 of 5 to the x is equal to log base 10 of 4 to the x plus 1. And so from here, we bring our x's down, or our powers down, sorry about that. So we have x of log base 10 of 5 is equal to x plus 1 log base 10 of 4. Extra set of parentheses there. All right, so what we're going to do next is we're going to distribute this log to both um, the x and 1. So rewriting this, we have x log of base 10 of 5 is equal to x log base 10 of 4 plus log base 10 of 4. So what we're really going to do here is we have an x value on this side, so we're going to bring that over. So we're going to subtract an x log base 10 of 4. So rewriting this, we have x log base 10 of 5. When we're subtracting x log base 10 of 4, it's equal to our log base 10 of 4. Forgot the x there. All right, sorry about that. All right, so if we keep going, we'll notice both of these factors have an x in them, so we can factor an x out. So we have log base 10 of 5 minus log base 10 of 4 is equal to log base 10 of 4. All right, from here, we'll divide off the log base 10, write that out for no reason, log base 10 of 4, and we'll divide our log base 10 of 4 over here by log base 10 of 5 minus log base 10 of 4. And so what you're left with is x equaling log of 4 all over log of 5 minus log of 4. And if you plug this into your calculator, you're going to get around 6.2136. All right, just looking at this again, I just want to point out that I was a little messy here, and this should not be a base, and this is actually our log 4, log base 10 of 4. Just wanted to point that out. And also, I just wanted to make sure we're plugging this into the calculator correctly. So we have our log base 10, our common log, of 4, and we're dividing it. Make sure you have your parentheses, so your log of 5 minus our log base 10 of 4, and then another set of parentheses. And so that gives us our answer of 6.2125. And it looks like I'm running out of time on this video, so I'll probably be making a second video to cover the last half of the notes.